The size of internal RAM is 128 byte. So the addresses that also we have seen, address of RAM. The memory is growing in upward direction in 8051. For other controllers, it may grow in downward direction, but here it is growing in upward direction. So 128 bytes means if you write addresses in hex, it will start from 00 and last address will be 7FH. You try to write in hex. If it is classroom lecture, then in every semester, I tell student to write all these addresses. So you can do also this practice 01, 02, like that. If you write 128 addresses, the last address is 7FH. So this is the size of internal RAM. This internal RAM, 128 byte internal RAM, is divided into three parts. Listen it carefully. The internal RAM memory of 8051 is divided into three parts. The first part is now shown here. This is called a working register part or register bank part of RAM memory. Its address starts from 00 and last address is 1FH. So this is the first part whose address starts from 00, last address is 1FH. This register bank part is divided into four register banks: bank 0, bank 1, bank 2 and bank 3. So there are four register banks in this RAM part of memory. Each bank has 8 registers. Here registers are written R0, R1, R2 up to R7. These R0 to R7 are registers of bank 0. Similarly, R0, R1 up to R7, these are the registers of bank 1. R0, same names are given. R0 to R7 for bank 2. R0 to R7 for bank 3. So the name of registers are same, R0 to R7. Each bank has 8 register, R0 to R7. Then how microcontroller will come to know? Suppose in instruction you have not studied till now, but I will just give you one example. Suppose there is a move instruction. I want to transfer data in register R0. So instruction is like that. You are going to study it in detail. So I want to move contents of accumulator to register R0. If I write this type of instruction, how microcontroller will come to know which R0 I want to use, whether it is of bank 0, whether it is of bank 1, bank 2 or bank 3. How it will come to know? It will go to PSW register. Just now we have discussed about program status word register and these 2 bits of PSW register. Microcontroller first go to PSW register. It checks these 2 bits of PSW register. Both are 0. That means the register user has mentioned in instruction is of bank 0. That means this register. If it is 01, it will take the register from bank 1. If it is 10, then this arrow. If it is 11, then arrow of bank 3. By default, when we switch on a microcontroller or when we reset a microcontroller, these 2 bits are 00. That means by default, we are using bank 0. We generally won't change the bank. We use this R0 to R7, bank 0. But you can change it by changing these 2 bits of PSW register. We can change it using instruction. But by default, these registers are from bank 0. Otherwise, means if you don't want to use the name of register, you can use addresses of register. Here the addresses are written. Address of this R0 is 00. R1 is 01. Address of this R0 is different. That is 08. Address of this R0 is 10. This R0 is 1. So you can use addresses also instead of R0. But generally we don't remember address. You are not going to remember that the address of R0 of bank 3 is 18H. Instead of that, you can change this data and you can name this register R0 to R7. But both way is possible in 8051. You can use addresses or you can use name of register. So first part of RAM memory is register bank part. There are 4 register banks: bank 0, bank 1, bank 2, bank 3. Each bank has 8 register. The name of 8 registers are same in each bank, R0, R1 up to R7. So there are 32 memory locations, 00 to 1FH. User can store any data in this register. You can use it to store a data. This is first part. The second part is bit byte addressable part. Here it is written bit addressable, but actually it is bit byte addressable. So here bit is written, but it is bit byte addressable. So what is mean by byte addressable? This memory is byte addressable. So this address is of this 1 byte. 8 bits you can store. The size of register is 8 bit. R0 register, R1, all these registers are of 8 bit size. So 1 byte you can store at this address. So that's why it is called a byte addressable. So these addresses are byte addresses. You can address 1 byte. But for this second part of RAM memory, whose address start from 20H to 2FH. After 1FH, next address is 20H. That you must know the hex number. So if you add 1 in 1FH, you will get 20H. So 20H to 2FH is bit addressable, byte addressable. So byte address we have seen, these are byte addresses. So if you want to store a data at this memory location, you can use address 20H. For this location, whole 8 bits, you can use address 21. But you can use a single bit also. You can address one single bit also. If you want to read a data from this one bit, single bit, you can use a address, bit address, and bit address is 00H. Bit address for this single bit address is 00H. For next bit address is 01H. For next 02H. The last address, because 8 bit of data you can store here, so last address is 07H. Next address for this bit is 08. 0FH, 10217. All these addresses written here are bit addresses. You can use read or write one single bit also if it is bit addressable. This is bit and byte addressable. So if you want to read or write whole byte, you can use these addresses which are written externally. Hope that you are understanding. So these are byte addresses and these internal addresses are bit addresses. For this particular memory area, you cannot read or write single bit. You have to read or write whole byte, each byte. But this area is specially designed for this. You can read or write either whole byte or you can read or write single bit. And that's why it is called bit byte addressable. That is second part of memory. The third part, which starts after 2FH, is 30H, starts at address 30H. So 2F, if you add 1 in 2FH, you will get 30H. So last part is 30H to 7FH. The whole RAM memory is 00H to 7FH. So actually I have shown it side by side, but it is after this part resides above this. This part reside about this second. Just for simplicity, I have drawn here like this. This is general purpose memory area. It is also only byte addressable. You can store a data, you can read a data from this general purpose memory area. Only this part is bit addressable. So remember that the internal RAM is divided into three parts. The first part is register bank. There are 4 register bank. Each bank has 8 register. All registers are of 8-bit size. The second part is bit byte addressable, where each individual bit has given an address and we can read and write this individual bit. And the third part is general purpose memory area, where you can read or write a data, 8-bit of data. Now question may arise. तुमच्या डोक्यात यायला पाहिजे होता हा क्वेश्चन, आपल्याला आला पाहिजे होता की address of this bit is 00 and address of this R0 register is also 0. दोन्ही याचा ऍड्रेस 0 आहे. ऍड्रेस ऑफ दिस वन सिंगल बीट इज 0 and address of R0 is also 0. If in instruction कळणार नाही तरी बघा, as an example I write suppose 00H. या 00H मध्ये I want to transfer a data of accumulator. Now how microcontroller will come to know whether user want to use this register or user want to use this one single bit. आता microcontroller कसं कळेल? So for that, bit addressable instructions are different and byte addressable instructions are different. So this is about internal RAM. Hope that you all understood this. So next is internal and external RAM memory. So you have studied how internal RAM is organized. But what about external RAM? As I told you that the internal RAM, so internal RAM, you know now, there is 128 byte. But what if my data is greater than 128 byte? I won't be able to store this data in 128 byte memory. In that case, we can interface external memory also. We have address bus, we have a data bus. So you can purchase external RAM memory chip and you can interface it with your microcontroller. Now, how these addresses are given now for internal and external memory, that we are going to see now. So this is 128 byte internal data memory. It starts from 00H, ends at 7FH. So this we know, internal RAM memory. Now I want to connect external memory. So before that, here SFRs are shown. Check here. After this 7FH address, the addresses are given to SFRs. These are special function register. The address start from ATH, next address, and then last address is FFH. In block diagram of 8051, SFRs are shown above internal RAM. So these are the SFR. Now what happened here? This is internal RAM. These are SFRs above this internal RAM. And we can interface external RAM memory. Here it is written external data memory. The maximum memory, minimum can be anything. It can be 0 also. But maximum memory you can interface is 64 kilobyte. And now you know the answer. Why maximum memory is 64 kilobyte? Why it is 64 kilobyte? Anyone can answer? Why maximum memory is 64 kilobyte? Yes, because address bus is 16 bit. That's why maximum memory we can interface is 64 kilobyte. Now see here what happened. The addresses for internal RAM 00H to 7FH and addresses for external RAM memory 16-bit addresses are shown here 000H to FFFFH. If it is 64 kilobyte, last address is FFFH. This is 8-bit address, but you can write it in 16-bit also. Add 2 zeros here in hex. Here also you can add 2 zeros. So we can say that for internal data memory, address 000H to 007FH and external data memory addresses are 0000H to FFFH. Again, here question is how microcontroller will come to know whether 000H address is of internal memory or is of external memory. For all these addresses, I am taking this example 00. All these addresses are available in external memory also. Somewhere here you may get address 007FH. इथे कुठेतरी हा ऍड्रेस असणारच आहे. So these addresses are common for internal and external memory. If you specify these addresses in instruction, how microcontroller will know whether it is address of internal RAM or whether it is address of external RAM. For that, separate instructions are again used. When you study instruction, remember this thing. Now, keep in mind, when you study instruction, you will come to know. Here I have written many times move instruction. So move is called a mnemonic. This is used for internal RAM. To read or write data from external RAM location, instruction uses move X. You are going to study it afterward, but just to clarify it, I'm writing here. This instruction is used to read or write data from internal RAM, whereas X later is used for external RAM. So whenever microcontroller sees this instruction, it will go to internal RAM. And when it will see this move X instruction, it will go to external RAM. This is simple. Separate instruction, same for bit and byte also. So this is used for uh, external RAM. So 64 kilobyte of external RAM plus 128 bytes of internal RAM. This much data memory we can interface, RAM memory. That is written here. Instructions are different for internal RAM memory and external RAM memory. So what you have studied is related to RAM memory. Now just 5 minutes are there. We'll go through the ROM memory. The ROM memory is simple. Internal ROM memory which we are going to store a program. So there are, just listen it properly. There are two combinations you can use for ROM memory. So this is the first combination. You can use whole 64 kilobytes of external ROM memory. Here it is shown. Whole memory. I am not using internal memory. Internal memory uses नाही करायची, त्याला block करून टाकायचं. Use whole 64 kilobytes of external memory. This is one possibility. The second is you can use internal ROM memory of 4 kilobyte that is available. So 000H, so 0FFFH. These are the addresses given for internal program memory. Plus you can use 60 kilobyte of external memory. 4 kilobyte we are already having in our 8051. 60 kilobytes will connect externally. So total ROM memory can be 64 kilobyte only for RAM additional 128 bytes we can get. But here you will get only 60 kilobyte of memory. The choice is yours. You can use whole external memory, or you can use a combination of internal and external memory. For this combination, you can see the internal addresses will be from 000H to FFFFH. The next address will start for the external memory. So external memory address will be from 100H to FFFH. So continue, addresses are in continuous location. Here for whole external memory, all addresses are given to external memory. Now again point is that how microcontroller will understand whether user is using whole memory as a external or user is using this combination of internal and external. So how microcontroller will come to know? It will come to know through this EA bar terminal. In pin diagram of 8051, we have seen EA bar terminal, that is external address enabled terminal. When EA bar terminal, user has to connect it to ground or to VCC. VCC is plus 5 volt. For programming, it should be greater. So when this EA bar terminal is connected to ground externally to your kit, you have to connect it to ground if you want to use whole memory as an external memory. External address enable. So connected to ground, it is active 0. So when it is 0, whole external memory is enabled. When it is 1, user can use an internal plus external combination. Hope it is clear to you. EA bar is external address enable. It is hardware pin. So we have to connect it either to ground or to VCC to select the ROM memory configuration. So connect it to 0. If whole memory we are going to use as an external memory, connect it to logic 1 when you want to use a combination of internal ROM and external ROM memory. Maximum memory in both the cases you can interface is 64 kilobytes.